We always do. No, yeah, no, I wouldn't say I was. I wouldn't say I was somebody who did much of that. But within reason. I don't think I was a difficult person. Within reason. Okay, so what I want us to quickly do is to finish this. So, yes. Let me double check. Because otherwise people will come find out where I stay.
Yeah, we'll find you. Especially me. I know how to find people.
So, yeah. So it is recording. It is recording. So here they say, in a small lotto, okay, using digits 0 to 9 only, the number of times digits 0 to 9 turned up in a run of 300 selections are summarized in the table below. Okay. So there you have it. There's your frequency. Can you see? You've got one row this time. Test the claim that the lotto is fair. Therefore, that the distribution is uniform at a 10% level of significance. So already, we then know we need to go step number 1, our assumptions. We are saying H0. What are we assuming? What is the situation here? We've got a lotto, and we're saying that we have these 10 digits, 0 all the way until 9. And we're saying you can get any one of these with an equal chance. It's a fair lottery. Okay, we're not saying that number 7 you're likely to get. You're more likely to get than number 3. We're saying all of them have an equal likelihood of being drawn. Okay, so what is our H1? Oh, sorry, H0. Our null hypothesis.
The distribution is
Yes. The distribution is uniform. The distribution is fair. Okay. Okay. So here you can say, is fair. The lottery is fair. Yeah, let me do that rather. Lottery is fair. Lotto is fair. Is fair. Okay, and then obviously H1, what are we saying? If you want to make your life simple, you just say H0 is not true. Simple as that. Okay. H0 is not true. So that's step number 1. We now go to step number 2. We need to get what? Our decision rule. When do we reject? When do we accept? And before we can get our decision rule, we know we need to get our degrees of freedom. Now, in this test, it's different. We're looking at likelihood. In the previous one, we were looking at what? Homogeneity. Okay? Are these variables the same? That's what we're looking at. The smokers, are they the same within the different age categories? Here, we're looking at likelihood. What is the likelihood of getting a 0? What is the likelihood of getting a 2? What is the likelihood of getting a 4, 5, 6, and the rest of it?
so does that mean that the F formula is going to be different? But it's not on the formula. What? Let it go. Let it go. How many marks?
You die over here. You can't get your decision rule without having your degrees of freedom. So this question ends right here if you don't know these formulas.
And these are the two different ways of the norm. Like different formulas of TF. The last one I did was the row minus it was the rows and the columns.
I'm scared to answer. Guys, why do you do this to me? Oh, let me show you the different types that you can get. There you go. Take a picture of that. Can you see? Is it still okay? And it's not including the top one. Okay, so let's start here. Take a picture of this one. This one. This is the one we're using right now. Okay. Just want this portion here. Oh, actually, no, I lie. Because this also explains it. So you can actually just take a picture of, let's see, is there a title there? No, there's no title. Okay, yeah, that. Take a picture of that. Okay, again, we're using the livelihood ratio test. Okay, that's what we're using right now. Then here are your other degrees of freedom. You guys, within your syllabus, you might not use each of these. I'm just making sure it's the right. You might not use each of these. But if you were with us yesterday, you will see that we definitely used the first one there. We used the second one, and now we're using the other one. So yeah, you need to make sure you have those three at least, because they've been used in your revision questions. Okay? And so far, you've seen that the things we've been revising, the things we've been practicing, are the things that have been coming. Ne? We agree on that much. Ne? Just making sure. Okay. Guys. Okay, so here we are. So K is your categories. We have 10. M, you're looking at your, what do they call this? Predictors. And then -1. We don't have any predictors in this case. So if we were doing linear regression, for instance, and we said we have 2 independent variables, all right, which are then predicting your dependent variable, for example, that's where something like that might come into play. Okay, so for now, it's just 10 minus -1, which gives us 9. Okay, but then we also know we need alpha, or our fish, which we know is 10%, our level of significance. Now we can get our chi-square equation. What is it, guys? What is it? 21. My sister. 21. Please double check. We're looking, 9 is the degrees of freedom, and then 10% is your and then please don't go and look at a different table also. So this is what I was doing yesterday. Maybe I should also do it today. It's the same as 0.1. Okay, right. So now we have that. We have our decision rule. Again, we are basically saying if our chi stat is greater than this 14.684, we are going to reject the nil hypothesis.
How do you know which one I will reject? Is it based on the question? If it's yes, then you will reject it.
Yeah, it's always, remember, that's why we set up our assumptions at the beginning. So we know, what did we say for H0, that we are rejecting it. Whatever we said for H0. What did we say for H0? Okay, it's less than our chi crit, so we're accepting it. Make sense?
Wait,
Why are we
it's
choosing
lesser than that?
So it's lesser than that at the end.
Yes,
You will accept it.
you will accept it. Because that's the opposite. Yeah? Ask me.
Assumption. It says, and its machine was fair.
Yeah,
That is
Yeah.
only the assumption.
that is the assumption.
What?
The lotto is fair. Any one of those numbers might win. Any one of those numbers can be drawn. It's fair. That's our assumption.
Okay.
So if we say, tell me, continue your question.
Okay. So if we are saying it's fair, why is it not equal? Why are we looking for smaller than? If it's smaller than 14,68.
This is our assumption, isn't it?
Yes.
This is our assumption. What we assume to be the case. Okay? It has not got an influence on the smaller than or equal to. So here, remember, we're also dealing with categorical data. If we were dealing with numerical, that's when we would have space or wiggling room to start to say, but wait. What exactly are we looking at? What is the manager's claim? And then say, are we looking for less than? Are we looking for greater than? What's going on? So here, this is what I was saying. This is actually easier because whenever you get your chi critique or crit, it's always going to be like this. If your chi stat is greater than, we reject the new hypothesis. Always going to be like this. This is always going to be the case. The only thing that will change there is this might be 21 something, it might be 6, it might be 7, it might be 8. You get what I'm saying? But it will always be if our chi stat is greater than our chi crit, then we are going to reject the null hypothesis.
It's like the stats is reality, hypothesis. So in reality, it tells us it's the world, then obviously it's rejected now.
I tried my best.
No. No. I understand.
Yeah.
I understand what's happening.
This is now. I think you're still in learning unit 8. That's the thing. And this is now where we distinguish ourselves from learning unit 8. My sister, don't do that one.
No.
Yeah?
Not like that. I'm just saying, this is going to be always like this.
In terms of this here, we reject.
Yes.
As long as this criteria is met, where our chi statistic is greater than our chi crit. Yes, always. That you can cram. Okay, all right, so let's go on. I want to finish so we revise next week. I might bring someone from the Reserve Bank to come and revise with you guys.
Really? And what? Really?
Yeah, I'm serious.
Are you serious?
If they're available, they'll
They
come.
must also come with job offers.
Now you see, now they won't come because they can.
I'm kidding.
So we've got our decision rule. Now we need to move to step number 3. What did we say step number 3 was? Calculate expected value and our chi stat. Right. So I was trying to do this table to save us some time. But I think in the interest of time, I'll just copy this one here and we'll just explain it. Let me screenshot. Okay. So here, these are observed. They gave us these. isn't? Okay, we need to calculate these ones here. And we know the calculation for this FE is equals to what? How do we calculate that?
The same as last time.
I know. It's a valid question.
We are saying row total, isn't?
Yes.
Divided by?
Column.
And then sample.
Yeah.
Times column. Don't write this
Why?
because we're discussing first.
No.
No, we are discussing it first. Divided by the total sample. Total sample. Or sample total, sorry. Sample total. Let me try and be, or yeah.
So it's not the same.
It's not the same.
I know.
It's not the same. Because I wanted to prove a point. Remember what we are assessing here. We are saying that these things are equal. So the sample total is 300, isn't it? And we're saying each of these has an equal chance of being selected. So basically we're saying that each should then have been selected 30 times by those who are in the sample, because each one has an equal chance. Okay, so this is why you see here, if you look, all of these, the value is the same. The expectation is the same. Isn't we're saying equal likelihood? Is it making sense? And this is one, we had a similar question like this yesterday, where they told us, I can't remember what was the question, but again, we were looking at where everything is supposed to be the same. Okay, there's supposed to be an equal likelihood, and so we did not calculate the expected the same. We had to just give an equal amount to each possible outcome. In this case, each possible digit. Okay. So now off of that, we can now calculate our child statistic for each outcome, and then we add them all. And when you add them all, again, you're going to get an amount, and that amount is 8.37 this time. So then we go to step number 4. And step number 4, we're saying compare. Step 2, the decision rule, and 3, which is your chi statistic. So here, our chi statistic is 8.37, and we calculated our decision rule or our chi crit to be 14.684. Is it greater than or less than? What's the story? It's less than. So what are we doing? Yeah, what are we doing? Yeah, listen to your friend. We accept the null hypothesis. It's right here. Can you see? We said if it is greater than, we must reject. Here it is less than, isn't? So we must accept. Other books, they might say, do not reject. But not rejecting is the same as accepting. Can you see? Accept HO. You are done now with step number 4. What's happening there, my friend? Okay. So here we are. Step number 5, we now need to conclude the management claim and interpret. So here, my friend, yeah, tell me, what is our interpretation? What's going on here? What is the management conclusion? What's the conclusion of the management claim? What are we saying? No, I'm asking everyone. Uh-huh. Yes, we do not reject HO at 10%. Yes.
Oh, you're alpha now. Yay, all right.
Yes. We do not reject the null hypothesis at 10% and therefore conclude what? What do we conclude? Yes, we conclude the lotto is fair because we're saying we accept H0. H0 says what? The lotto is fair. This is making sense now.
Yes.
So that's why I say, as long as you've done your things right, interpretation in stats should not be a problem. Because you're just recommunicating what you were testing for and then saying yes or no,
So
true or false.
is that 14,68 or like the chances of it being right? Like what is that?
It's a threshold. So let me show you. So with your chi distribution, it's not like your normal distribution. Normal distribution, we know we've got a bell-shaped curve. With your chi, it is skewed to the right. So your distribution typically would be something like this. Okay. So with this criteria, it's the point where we reject. In fact, I've done this wrong here. It should probably be something like this. Okay, no, I lie. I actually was right. Okay, so the criteria is here, 14.684. And this is your what? What region is this? Yes, it is positive. You are right. Rejection region. Because what did we say? If our our chi stat is greater than, which means that it falls in this region. Let me use a different color. If it's greater than 14.68, it means it falls within this region. Can you see that? And that's rejection region. And that means that we are then rejecting the null hypothesis. Can you see that? Am I answering your question? Are you sure? Okay. Yeah, guys, your school fees is finished for today. Are we, any questions? Anything you guys want to discuss before we call it? Please go and do 2022, 2023. Only the questions pertaining to 6, 7, 8, and 9. Because the other stuff revised, we should know by now. We won't have time to go over. All right, guys, we're almost done now. You won't be seeing me for much longer. I'm sure you're excited as I am. Ne?
I'll be the
Well, you've been bunking, so that says a lot.